In today's lesson, we will start with the topic of median, quartiles, percentiles, range, and interquartile range. In the previous section, we have learned how to estimate the cumulative frequencies from a cumulative frequency curve. What else can we estimate from a cumulative frequency curve? In fact, we can estimate the median and other useful statistical measures such as quartiles and the interquartile range from a cumulative frequency curve. First, we will recall how to find the median of a set of discrete data and then learn how to find the quartiles. Before returning to finding these statistics from a cumulative frequency curve which is used to display continuous data. Now first we will find out the quartiles, interquartile range and range for discrete data. We'll see what is median. The median is a measure of the average and is the middle value. When the data points are arranged in an ascending order. Discrete data. Discrete data refers to a set of data which only takes on distinct values e.g. for example the data showing the number of phone calls received in a day. Can only take on distinct values such as 1, 5, 12, etc. But not 1.5, but not 1.5, mixed fraction 4, 2 by 3, etc. Now we're going to take an example. Here we have a data set A having the discrete points 2, 5, 6, 7, 8, 9, 14, 16, 20, 21, and 30. The total frequency n in other words, total number of data values is 11. So we will count the data values. Those are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the total frequency is 11. Now to find out the position of the median. So to find out the position of the median, is equals to n plus 1 divided by 2. So here the value of n is 11, so we have 11 plus 1 divided by 2, and it will be equals to 12 divided by 2, and it will give us 6. So the position of the median is equals to 6. Now we will again rewrite the data values. So we have 2, 5, 6, 7, 8, 9, 14, 16, 20, 21, and 30. So that's why the median is 9. Here we will mark the median. That's why the median is 9. We see that the median 9 divides the dataset. See that the median 9 divides the dataset in two equal halves. So the one half is this, having the 5 values, and the other half is this. With 5 values on each side of the median. So we consider the 5 values on the left of the median. We're talking about the 5 values on the left side of the median. The middle value of these 5 values is 6. So the middle value of these 5 values is 6. And it is called lower quartile. Or the first quartile Q1. The first quartile can be considered as the first quarter value, where about on one quarter or 25% of the data is less than or equal to this value. Now, since the median is the middle value or the second quartile value, second quarter value, so we have Q, we will call it Q2. The median is also called the second quartile Q2, where about half or 50% of the data is less than or less than equals to this value. So here we have the lower half. Now we consider the 5 values on the right side of the median. The middle value of the 5 values is and it is called the upper quartile. Or the third quartile Q3. Where about 3/4 or 75% of the data is less than or less than equals to this value. So here we have the upper half of the data values. We can see that quartiles obtained by the above method divide the dataset, which is arrayed in the ascending order, into 4 roughly equal parts. So here we have the first part, the second part, the third part, and the fourth part. So these quartiles roughly divide the dataset into 4 equal parts. Now consider another set of discrete data arranged in the ascending order. So here we have our dataset B having the dataset values. So here we have 2, 5, 7, 7, 8, 9, 10, 10, 11, 21. Now here we have 9, 10, 10, 11, 21, and 30. From the table, we observe that the total frequency, the smallest value, the largest value, and the median are same for both the sets of data, for the set A and set B. Only the lower and upper quartiles are different. But what can the lower and upper quartiles tell us? We can only say that in general about the, and not exactly, 50% of the data is less than or equal to the median. Similarly, we can only say that in general about 25% of the data is less than or equal to the lower quartile, and about 75% of the data is less than or equal to the upper quartile. Now we are plotting the histograms representing the data values in the dataset A and in dataset B respectively. So first histogram for the dataset A, we have along y-axis we will take frequency, and we will scale the x-axis, y-axis with the points 0, 1, and 2. Now along x-axis we will take the data points or the data set values. So here we have 2, having the frequency 1, 5, 6, 7, 8, 9, 14, 16, 20, 21, and 30. So here we have a range from the smallest value to the largest value of the data set. This is a range. And here we have 6 lower quartile, 9 is a medium second quartile, and 20 is the third or the upper quartile. And this is interquartile range. We can notice that histograms help us visualize the spread of data values more clearly than the numbers. Now for the dataset B, along y-axis we are plotting the frequencies, scaling the y-axis like 0, 1, and 2. Along x-axis we have frequencies. Now along x-axis we are taking the values of the data points, discrete data points. So here we have the values 2, 5, 7. The frequency of 7 is 2 because it repeats 2 times, or it occurs 2 times. Here we have 8, then 9, then 10 occurs 2 times. So here we have the bar of height 2 for 10. Then we have 11. Then 21. And in the last, we have 30. Here the range is from the smallest value to the largest value of the data points. Here is the range. And now the median is 9, which is also a second quartile. The first quartile is 7, or we call it lower quartile, and the third quartile is 11, Q3. And this is a interquartile range. Interquartile range. We notice that data values are spread differently. Even though the total frequency, smallest value and the largest value and the median are same for both the datasets. Range and interquartile used to measure the spread of the dataset. For dataset A, range is equals to largest value minus smallest value. So the largest value in the data set A is 30 and the smallest value is 2. So 30 minus 2 is equals to 28. Now for data set B, again range is equals to largest value minus smallest value. So here we have 30 minus 2 is equals to 28. Now we can see that the data values in the data set A are more spread out from 6 to 20. So the interquartile range is equals to Q3 minus Q1. And for the dataset A, we have Q3 20 and Q1 6. So 20 minus 6 is equals to 4. Now for dataset B, values are clustered around 7 to 11. So the interquartile range is equals to 3 minus Q1. For the data sets, the third quartile range is 11 and the first quartile range is 7. So 11 minus 4 is 11 minus 7 is equals to 4. And 20 minus 6 is equals to 14. The interquartile range of a dataset describes the distribution of the middle 50% of the data values around the median. Range depends on only largest value and the smallest value and does not take account of all the other values of the data set, and it is affected by the extreme values. Interquartile range does not affected by the extreme values. Remember, when n is even, median is the mean of the two middle values. Median is the mean of the two middle values. When n is even, when number of data in the lower half is even, Q1 is the mean of the two middle values. When number of data in the upper half is even, Q3 is the mean of two middle values. Now after learning how to find quartiles range and interquartile range for discrete data, let us look at the quartiles, interquartile range and range for the continuous data. The cumulative frequency curve displays continuous data since the time spent using the computer can take any value within a range of numbers. Although the number of students, cumulative frequency is supposed to be discrete. We will treat the cumulative frequency as continuous since it is displayed on the vertical axis from 0 to 40. This will affect how we find the position of the median. So first we will plot discrete data with 40 values. The median position is is equals to n plus 1 divided by 2, and it will be equals to 40 plus 1 divided by 2, and it will give us the value 20.5, i.e. the median is the mean of 20th and 21st values that have been arranged in ascending order. It makes sense because there are 40 values from the first value to the 40th value, and the middle value is 20.5. But for continuous data, from 0 to 40, and not from 1 to 40, the position of median is equal to n over 2. So it will be equals to 40 over 2, and it will gives us the value 20. It makes sense because the middle of the vertical axis from 0 to 40 is 20 and not 20.5. So to estimate the median from a cumulative frequency curve, we find the position of the median using n over 2. So to estimate the median from a cumulative frequency curve, we find the position of the median using n over 2. And for discrete data, to find the position of the median, we use n plus 1 over 2, since we have already discussed. Now we are looking for the data value corresponding to the cumulative frequency of 20. So from 20, we will draw a horizontal line until it intersects the curve. Now from the point of intersection on the curve, we will draw a horizontal line. We will draw a vertical line until it cuts the horizontal axis. So here we have the value 5.7. So that's why an estimate of the median Q2 is equals to 5.7 hours.